EBTS, his main objective is to share his industry experience with students. EBTS has numerous reputed customers from all over India and also conducted several FTPs in various institutes across India. Now I invite Sir to enlighten us with his words. Over to you, sir. Thank you.
Sir, you can start, sir. Shubhina sir. Participants, all of you, please mute your mics. Vijay Gopal, please mute your mic. Vijay Gopal. Yeah. Sir, your mic is muted.
Yeah, good morning to all of you, and thanks for joining this session. I'm very thankful to sir for giving me this opportunity, and I have small issue with my laptop, which has got automatically restarted because of the Windows restart. So it should come up any moment. Once it happens, I will do the hands-on session. But for now, I will focus on the theory part. You guys can able to see my screen. Okay. Before I start, I just wanted some few things which I want to highlight. First of all, I wish all of you are doing well in this current pandemic situation. And while we are in this situation, the only constant in life is change, and we have to continuously upgrade ourselves, cross skill ourselves, and upskill ourselves in whatever the latest technologies we have. And that is something which I've been doing, and I've been imparting my knowledge to the students and faculties. So in today's sessions, my main objective is to tell you something about machine learning, specifically on the regression models and the classification models. I want this session to be very, very engaging. I like you also share your thoughts, because what I personally feel that if all of us get engaged, we enjoy the session, right? And as much as I can share whatever limited knowledge I have, I would request you, all the faculties who come from different backgrounds, some of you are research scholars, some are experienced teachers, please share your experience. That will help not only me, but the entire audience who is there in today's session, right? So having said that, I just wanted to understand from you guys, what are the things you have learned in the last 3 days. What I understand, based on the topics I've seen in the schedule, you have already covered the mathematical foundation. You have covered obviously the basics of machine learning, and also you have covered unsupervised learning. Is my assumption correct?
Yes, sir. Yes,
Can I?
yes.
Is that correct?
Participants,
Okay.
please respond.
Request you to guys please respond, because please unmute and talk. That will be, that will help me, or that will help me, please. Okay. So I'm assuming that you are not aware of the supervised learning. That's why I'm coming and trying to make you understand.
Manas, you
Now,
also
I just
respond.
wanted to
Manas,
understand from you. I know
sir,
you have understood what is machine learning. You have already understood the concepts. Can somebody define or tell me whatever you have learned about machine learning in your last two sessions, whenever it has happened? What is machine learning? Anybody?
That is, let the machine learn by themselves by giving some data and instructions.
Learn the, very nice. So you're saying we should feed data into the machine, and the machine learns by itself. So what happens based on that? So what does the machine, when you feed data into the machine, what happens?
That is, after that we are giving some algorithms or classifiers, something like that, to do our requirements.
Okay, very nice. Anybody else has some different thoughts? Okay, so the first and most important thing, as sir has likely said, is you need to have data, okay, for which you are going to train the particular machine. Okay, so first of all, you need to have input data. You need to have input data. You feed that input data into a machine. As machine learns by itself based on experience, based on experience, the very important word, based on experience. And what the machine does, it it tries to derive a pattern. So you derive a pattern out of the data. And when you derive a pattern out of the data, that pattern will help you to predict the output. So the output which is predicted because of the machine which is getting trained, the machine which is predicted, that particular data is compared with the actual output. And you will see whether your actual output and the predicted output from the machine is matching. Only if it is matching, that means you say my model, my machine learning model is fit or optimized for this specific set of data. Did I make sense what I said? Anybody has any questions on this, what I said?
Participants, please interact. Make it interactive. So that
Request you to please interact. If you don't interact, then it becomes a monologue, which is not good for me.
sir, you can
Please,
see
please
the
interact.
chat box also, sir. Some chat box also you see, sir. Some answers are there.
Chatbot. Okay, let me just check.
They are saying data can be any format.
Yes, so data could be a normal data. It could be a image. Hold on, I'm just trying to. Where is the chat? Let me open the chat. Yes, so data can be in any format. It could be an image, it could be an audio visual, it could be normal text data. Okay, it could be any data. See, there are two types of data. One is structured and one is unstructured. Can somebody tell me the difference between a structured and an unstructured data, please? What is the structured data?
Structured data means it is represented in a tabular form.
Very nice. So our normal tabular form, like where you have a primary key, secondary key, you have field attributes, where you have a structured way of keeping the data, that's called structured data. What about unstructured data?
So normally data is collected from sensors and all. It will not be having any specific format. It will be very raw data. You have to give it. You have to clean it and give it a proper structure to use. It won't be in the usable format.
So correct. So essentially any data, for example, I have any social message, social networking message like a WhatsApp message or a Facebook, whatever I'm writing on Facebook, or whatever I am writing on any social network, or all images, videos, these are all unstructured because there is no particular structured data, right? And today the need is that you should be able to even detect images, okay, using machine learning algorithms. If you have heard of, I will come to this concept, but if you have heard of something called convolutionally neural networks, CNN, okay, today the, the way the things are happening is that we are going towards heavy high-end processing using GPUs, graphical process units, instead of CPUs. And that's where, because you have images, multiple images which are taking a lot of bandwidth, the size is very high, you need to have a high-end processor to process that image. And today there are machine learning process, you have algorithms by which you can even detect an image, okay, through this neural networks, right? Now let me give you a very classical example. Suppose I am the CEO of Hindustan Levers, and I have heard from the general public that they are not happy with a specific product. So what will happen is that I, as a CEO, I need to capture all this information. So typically what happens, if I am the person who is the customer, one, I could either call the customer care support. Number two, I can lodge the complaint on their website. Third, what I can do is I can put it on Twitter and post it. Another thing I can do, I can send a WhatsApp message to my peers. Now, as a CEO, I need to capture this information also, which is the unstructured data, which is obviously what is happening through your WhatsApp messages or Twitters. Or it could be a structured data where you're actually calling a particular person, where the person enters your complaint, which goes into a database. Or you're logging into a website, you enter the complaint, it goes to a structured database. But as a CEO, I need to capture even the unstructured along with the structured data. I should be able to derive a pattern out of the data so that I can know how much percentage of people are talking good about my product, what is the percentage of the people who are not talking good about my product, and based on that, I can take a decision whether I should continue my product, discontinue my product, or come out with some enhanced features. Okay, so this is how you will basically use algorithms to derive patterns out of the data, right? So does that answer your question, sir? Somebody who had asked about the data formats, does that answer whatever example I gave? Okay. I don't know where is the chat gone. Okay. So, Mr. Mohammad Billah, who had the question about this? Okay, structured format. Okay, Sunita, have you understood? I think she's having a microphone problem. No worries. So let us go ahead. So we talked about, so when I talk about machine learning, please understand one thing, you need to have input data. You need to feed the data into a machine. The machine will learn through experience. And once the machine learns through experience, then you will basically the machine will derive a pattern out of the data. And once it derives a pattern out of the data, you will compare the predicted data coming out of the machine with the actual data. And that's where you will propose a particular machine learning model if your predicted data and the actual data matches. Any questions on machine learning definition? If you have understood this concept, because later when I'm going to go through some more details, this should be very, it should be in your mind, embedded in your mind. Okay. Any questions? Otherwise, I'll go ahead. Yeah, sure.
Sir,
Please
good
go ahead.
morning. Sir, one question.
Good morning, Dhruv.
Sir, sir, just to, if you just help us to understand that the fundamental relations and difference between AI, machine learning, and data science, briefly.
Okay, AI is overall artificial intelligence, right? AI, within AI, machine learning is a subset. Machine learning is a subset of AI, okay? Because through machine learning, you are deriving a pattern out of the data. So the machine is basically simulating a human behavior, because typically human being, if you would have to derive a pattern out of the data, it would have been very difficult. So you are allowing a machine to derive a pattern. When I'm talking about deep learning, now this is another thing which is within machine learning. When I say deep learning, we are talking of neural networks. So there are basically artificial neural networks, you have convolutional neural networks and you have recursive neural networks. Okay, so as I said, for high-end processing of data, you need to that's why you have the neural networks which works similar to the human brain, the neurons. So deep learning is again a subset within machine learning, right? But AI is at the top. Then you have RPA, robotic process automation, where you use robotics engineering, like you create some mechanical robots. Then you also have repetitive business processes. You have got RPA tools like Automation Anywhere, which help you to automate various processes. Okay, if you want to program for a robot, okay, you can use RPA tools. Okay, so this is again another example of AI. Then when I'm talking of data science, see, data science is, and what is data science? It is basically what is the scientific way of analyzing data. So typically when I say I am a data scientist is a person that who understands the data, who can able to derive some sort of a relationship between the variables. Okay, and typically a data scientist comes with a functional knowledge where he understands the domain. Like for example, if I'm a healthcare, I can understand. I should be able to understand what is healthcare data. If I'm from retail, I should be able to understand what is retail data. So I need to understand the domain or the industry. I need to understand the data which is specific to specific industry. So data scientist becomes very important because he is more of a functional domain guy. And you also have technical people who basically are programmers, who will write scripts, Python scripts, okay, to basically write some, to understand the data and to write the scripts. So you will have in any project, data science project, you will have a project manager who will manage the project. You will have a domain expert who will basically help to interpret the data, and you have a technical experts where the domain expert will help to understand the data and convert the functional requirement into a technical requirement. And that is when the technical people comes into picture. Did I make any sense? Dhruv?
Yes, sir.
Sir, yes, sir. Yes, sir.
Sorry, Dubashish. Yeah, okay.
Yes,
So
sir.
you have understood, right? Okay, great. Thanks. Please ask me questions. I'll be very happy to answer. And please interrupt me anytime you want. Okay. Now, having told you about the AI evolution, having told you about what is machine learning, now I want to tell you what is a supervised. Can you tell me what is unsupervised model? I think you guys have already learned yesterday. What do you learned about unsupervised model?
Sir, unsupervised learning means where we are actually making the machine learn not through any training, but we are actually making the entire learning process of the machine is not being supervised or trained previously. So suppose if you take example of clustering, in this case we have some set of data points, and then we are finding that using different kind of algorithm to cluster the data points. So in those cases, we are not having another set of data based on which we make the model learn and then to apply. In comparison, if we take example of classification, where at first we train the model and then we test the model to check the validity of the model. So that is supervised.
Anybody else? Whatever you have learned yesterday. We have no
Sir,
response. Very
without
well.
any supervision about the classes, we are giving the data and grouping the data using the similarities between the points.
Correct. So the way I will say, unsupervised model, typically you don't have a pattern.
Unlabeled data.
The pattern of the data is unknown. Pattern of the data is unknown. For example, we talked about clustering. Now, what is the clustering? Suppose I go to a mall. In a mall, I have people coming in. I capture his income. I capture his age. I capture his income. I capture his spending power. Spending power could be 80%, 90%, whatever. I have some rule. So higher the spending power, higher the rule. Higher the value. So as a mall person or as a mall owner, I have age, income, and spending power. First of all, I cannot make out anything about the pattern. I need to derive a pattern as to whether the person, how much percent of the people are really thrifty, how many people are really spending a lot, how many people are conservative. That is where you create clusters, where you have groups of people with similar attributes. So you will have one group which is low income, low spending, another group which is high income, high spending. And you have to decide which is the population or which is the cluster group I need to target from my marketing perspective. So if I have a high income, high spending person, I can focus on those customers and come out with some more additional products. And if I've got a high income, low spending, I can come out with a different strategy where I can probably say that I can give some sort of promotional offer. Where if I give one product, I'll give another product free. So depending on the cluster I create, so clustering is grouping based on common attributes. And you don't have a pattern known in advance. You don't know what is the pattern of this data. You can't say that if a person has got high income, the spending power is going to be high. Not necessary. Or you can't say the person with a low age, high income will have a high spending power. No, you cannot say that. So you have algorithms which will dig out, which will come out with the hidden patterns out of the data. Okay, and I'm sure you must have heard of the KNN cluster. You must have heard about the SLOs. How do you find out the number of clusters? I'm sure that must have been covered. And also there is something called learning association. Has somebody told you what is learning association within unsupervised learning? Anybody? Am I audible? Yeah, yes, Drupashish, please go ahead.
Sir, please, if you explain also.
So what is learning association? For example, I go to Flipkart site and the Flipkart gives me a product recommendation. Or I go to Netflix site and the Netflix gives me movie recommendation. How does this movie recommendation come? How does this product recommendation come? These are all machine learning algorithms, unsupervised model, where based on your past movies, based on similar profile people who are logging into the site, it will propose you some movies or propose you similar products. These are called learning association. It tries to learn based on the profiles, similar profiles or your past, whatever you have selected. This is another example of unsupervised model. Okay, so you have a learning association, you have clustering. Now there is something called principal component analysis. I'm not sure whether it was covered, but that is also one example of unsupervised learning. So unsupervised learning is where the pattern is not known in advance of the data, and you have algorithms will try to dig out the patterns out of the data. Did you guys understand? Any questions on this? Because since you have already learned it, I just wanted to understand how much you have understood, and then I could add some points based on my inputs. Anybody has any questions on unsupervised model? Okay. Can anybody tell me what is a supervised model? What is a supervised model? Anybody, please? Anybody has any guesses? I mean, anybody who knows machine learning, please respond so that people can know.
In the case of supervised model, we understand that whenever we are building the model that is being supervised means the model is being trained based on some data, and then we are going to test the model by a test set of data.
You are going to test the model with a test set of data. Okay.
But
So
before
first of
that,
all,
we are going to train the model by
yes,
a set of data. So suppose if you are having 100 records, we can take like 75 records to train the model, and then remaining 30 we can find out that the accuracy of the model for testing.
very good, very nice. So first of all, what is a supervised model? In supervised model, you have a particular pattern which is known in advance. So the data pattern is already known. For example, when I have got y equal to mx plus c, what is this equation called in algebra?
Straight line equation. Slope of
The
the
straight
straight
line
line.
equation, right? It's a linear equation. So what is y? Y is your y-axis output, right? And x is your x coordinate. So what is y called in machine learning terms?
A
Predicting value.
response variable.
Predicting value.
So y is called a predictor.
Or dependent variable.
There are various terms you can use. It's called predictor.
Dependent variable.
It's called output. And the most important word, it is called a dependent variable. It is called a dependent variable. Okay. What is x?
Independent variable or input.
X is called an independent variable.
Or
It is
input.
also called a feature.
Yes.
Sorry, my mistake, probably my mistake, sorry. Y is output or dependent variable, feature or predictor. So X is called an independent variable. It is also called features. You will hear a lot of terms called features. What is a feature, right? So that is an independent variable. Okay, and what is M? M in machine learning terms, while you know it is called a slope in algebraic terms, it is called coefficient. Okay, now if I draw this line y equal to mx plus c, so as x increases, y also increases. So I have a sort of a straight line curve. So I know the pattern of the data. I know it's going to be a straight line. Okay, in this case, this is called regression. This is called linear regression because it's a straight linear line. Okay, now when you have y equal to mx plus c, so y, which is a dependent variable, depends on x. Now, is y a continuous out variable or a discrete variable? Anybody?
Sir, may I ask one question?
Sure, go ahead.
Sir, are you
Again.
presenting something, any presentation?
No, I am waiting for my present. Don't worry about the presentation.
Okay.
I will sending you, but whatever is in the presentation, I'm writing here. So let's
But
focus on whatever I'm writing. Okay, don't
we cannot able
let's.
to see anything.
Sir, are you writing something?
Oh, did I not share my screen?
No, no,
Sir,
sir.
not shared.
We
Only
think
blank screen is there.
Sorry. So please tell me if you are not able to see because I get
Yes,
involved
sir.
in it.
Yeah,
Please
you are
interrupt
not.
me immediately. Don't wait
You are
for.
not shared, sir. Not shared.
So you should tell me immediately because I thought I'm already. Now you can see.
No, sir, not yet.
no.
Yeah, you should be able to see my notepad.
No, nothing. Okay.
Now started
Okay,
sharing.
now.
It's coming. You can see the notepad, please.
Yes, sir. Yes. Now visible.
Sorry about that. Please let me know because once I get engrossed, I don't see whether I've shared or not. Please interrupt immediately.
Sure,
If you're
sir.
not
We
able
are
to.
doubting that.
No, don't worry. You should always, even if you have small doubts, please stop me because
Sir, please make it maximize the window.
I will do that. I will do that.
Not visible.
No worries. No worries. That's okay. Because I just want to make sure you guys understand. That's why I have a bad habit of writing because I don't have a blackboard to write. So as I said, in a supervised manner, pattern is known. Okay. So is y a continuous variable or a discrete variable? Can somebody tell me what is a continuous variable and what is a discrete variable?
Yes, Anishka Sukla.
Sir,
Yeah, you
a
can ask.
discrete variable is the one which takes integer values, and continuous variable is the one which takes values in intervals, values as interval.
When you say values as interval means what?
Like, sir, we talk of confidence interval.
But that is again a range, no? You're saying it will be say
Yes,
from
sir, it takes
20 to
range of
30.
values.
Yeah, but range of values will be anyway fixed, again a fixed set of values, right?
Yes, sir.
It is not changing. Y is a continuous variable because as x changes, y changes. So y is not fixed. It is changing depending on the value of x. So that's why y is called a continuous variable. Have you understood what I said? Why is continuous variable? Okay. Similarly, so in this case, in the case of regression, your y is a continuous variable and the y changes with the value of x. And since it's a linear line, your y will go on increasing or decreasing depending on value of x. The second type is called classification. Now, what is classification? Anybody can tell me how different is classification from regression?
So please pardon.
Can somebody tell me how classification is different from regression?
Regression is some kind of prediction where classification is actually assigned some level to an unknown data.
In both the cases, you're doing prediction. It's not that in classification you don't do prediction. You're doing prediction for both the classification and regression. In the case of classification, yeah, please go ahead.
Regression is basically, I think
Yeah,
regression
please.
is applicable for the continuous data.
Correct. That is why we call it continuous variable, right? So what is classification in that case?
Classification is applicable for the categorical data where the class levels are there.
Correct. So in classification, your dependent variable, okay, is having a discrete set of values.
Right.
So either I can say that a person is having cancer, yes, or not having cancer, no. Or person is going to buy a car or not going to buy a car. Or I could say that this particular image is either a dog, cat, horse, or so on. Or I can say this particular number could be value from 0 to 9. So I have a fixed range or fixed set of values, or which is called a labeled data, and this is called classification. But again, since the classification you have the output which has a discrete set of values, you know the pattern of the data. So as against unsupervised model where the pattern of the data is unknown, in the case of supervised model, you are basically having the pattern known in advance. And within supervised model, you have the regression. Now within regression, you could have a linear regression, which is all a univariate regression, which is having a single independent variable. You could have a multivariate regression, which is having multiple linear variables, or you could have polynomial regression, which is basically a polynomial nature. For example, I have y equal to mx plus m1x squared plus m2xq and so on. Can somebody give me an example of a multiple regression? A live industry example of a multiple regression based on the definition that I've given. Can somebody tell me,
Yes,
give me an example of a
Anishka Sukla, you can say, you can
So,
unmute and say.
Sir, like if we talk about the transportation cost for some item deliveries, so it can depend upon a number of variables, such as the inventory or maybe the distance or any other factors.
I think you need to give me a concrete example. Anybody else? For example, I say that the price of a house is depending on multiple parameters. One could be the size of the house, which floor of the I'm basically going to decide. The person is going to decide the proximity to the railway station, the proximity to the mall. There could be various such parameters which will decide the price of the house. So the price of the house is a dependent variable, and all these parameters which I talked about are the independent variables. So the price of the house will depend on the combination of this. Okay. Another example is I will have multiple, for doing cancer detection, there are multiple medical terms like medical tests which are there. Okay. Now that medical test, I will capture various report features, various numbers, based on the tests. And based on the combination of this test, I will decide whether the cancer is benign or the cancer is malignant. So this is another example of, okay, this basically becomes a classification model. Sorry, what I have told you is a classification model. The first one which I told you is a regression model, where you are going to decide the price of the house. Or I could also say that the price of a car, the price of the car may depend on the mileage it gives, the brand, the engine transmission, the velocity, the engine transmission, the gearbox, the various parameters we could have, right? So that basically explains me what is a multivariate regression. Another example I will give you, very, very important. I am a company. So in a company, what is very important for me is to maximize the profit. And my company's profit is depending on multiple parameters. Okay. It could be one, how much R&D expenses I have. Number two, what is my marketing expenses I have. Number three, what is my promotional expenses I'm doing, advertising I'm doing. All these will decide the profit of my company. Okay, so this is another example. Now, since profit is a continuous variable, it is not fixed, right? Profit will change depending on my R&D expenses. It will change depending on my marketing expenses. It will change depending on my advertising expenses. So all these becomes an example of multilinear regression or multivariate regression. Okay. Classification, I gave you an example of the cancer case where there are multiple parameters, multiple tests will decide whether a cancer is malignant or cancer is benign. Okay, so these are some examples of classification. As I said, detection of a number 1 to 9, detection of an image are all examples of classification. So have you guys are clear between the difference between a classification and regression? Any questions on this, please? Have you understood? Any doubts? Any suggestions? Okay, Anshika has said understood. Can I get a quick yes or no on chat? Sunita, you have not understood. What have you not understood? Sunita, can you unmute and talk? Oh, sorry, you said no. Okay. So the thing is, if I say yeah, you say yes means you have understood, no means you have not understood. Okay, please. Okay, I should have given the naming convention. Sorry about that. So yes means you have understood. If you have not understood, say no. Okay, that will be fine. Great. Now, having understood what is a supervised model and where you have the classification regression, I am going to explain you the process or the workflow, how it works. Very, very important. Please pay attention to this.
Sir, again, your screen is not visible. Please share.
Hold on. Why? Give me 1 minute, please. Give me 1 minute, please. I don't know what happened.
Sir, keep it in presentation mode.
Yeah, 1 minute. You can hear me, right? I think 1 minute. Hold on.
Yeah, can hear.
Yeah, please give me
But
1
you
minute.
have not shared.
Yeah, I'm just.
Mm.
Yeah, can you see my screen now?
No, sir, not yet started sharing.
Because it is already showing grayed out. Presentation mode.
You can unshare and again share, sir, again.
My actually that up arrow is grayed out actually, sir.
No, sir. Are you using laptop or mobile?
I'm using my PC.
PC, na? Then you
1
can
minute, hold on, sir. 1 minute, hold on, sir.
stop sharing, sir. Stop sharing again. Share it. Stop presentation mode. Here only one only coming. If it is presented means two
1
names
minute,
will
sir. 1
come.
minute, sir. So I will just. Okay, you can anyway hear me, right? I'll just get out of the PC. I'll come back. Okay. I just I'm still on the speaker, but I'll just give me 1 minute. Just getting into it. Okay, while this comes up, can somebody tell me why do you have a test a training set and why do you have a test set? So give me 1 minute. Sir, actually I'm 1 minute. Hold on. Let me try for my laptop now. It's come up. Give me 1 minute.
Or else you can rejoin, sir. You can
Hey, sir,
exit
1
and
minute, sir.
rejoin.
No, but sir,
Okay.
give me 1 minute, sir.
Okay.
You can hear me on audio, right? Just give me 1 minute, sir.
Audio is clear.
Yeah, yes, sir. I'm just going to my laptop because I don't know because I'm seeing the PC, but the presentation is grayed out. Actually, that up arrow. If it's grayed out means what I still trying to get in. Correct. So as Maria, I'm saying, so you have a training set. In training set, essentially what you do, you use the training set to basically train the model, but you need to have another set of test data which needs to check the accuracy of the model, and that is where you have the test set. And typically the proportion of the training set to test set is generally 70 to 30% or 75 to 25%. Sometimes it also be 80 to 20 depending on the volume of data you have. Okay, but typically in the industry it generally varies from 70 to 75 for training data, and test data is 80 to 75%, and test data is 25%. Just 1 minute, 1 minute. Okay, just let me just log out. So can you see my screen? I'm just sharing my screen.
No, sir, not yet shared. Sharing not yet started. Now started sharing.
Are you able to see my screen, sir?
Yes,
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 sir.
Yes, sir.
Yes.
Okay. Give me 1 minute. I will just open my presentation.
Yes, sir. Open your PPTs, then it will be good.
Can you see my notepad, everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now what I'm going to explain to you is essentially what is a machine learning workflow. Okay. Now when typically you get the input data, the data could be in any format. So there could be a lot of missing data, there could be a lot of junk data, there could be a lot of data which is it's not realistic. It is basically, for example, if I got age and salary, if I get some salary data of say age data of 75, 80, which is not valid, right? So there could be a lot of data which is unclean. Okay, when you get the data from your client, your data will be mostly many a times it is unclean. Okay. This is the slide I'm trying to explain. So when you have an unclean data, you have to do some sort of a pre-processing of your data. What is pre-processing? One, you have to take care of any outliers. Outliers means something which is not in the range. Means something like, for example, your age of a person is 100, cannot be a part of your payroll, right? For example, you have to take care of missing data. You have to take care of junk data. There could be a lot of such scenarios. Unless your data is clean, you will not be able to get an efficient result. Okay, so first and most important, you have to ensure that your data preparation in any machine learning project, the first and important thing is to do a data preparation phase. This data preparation phase is important before you start training the model, and typically 60 to 70% of your overall project time goes in data preparation. So you have to ensure your data is absolutely right. There is no outliers, there is no missing data, there is no null data, there is absolutely perfect data for you to basically give an input to your model. So this process is called pre-processing, or we call it the data pre-processing. Okay. After you have processed the data, so now you have got a process data. Now this process data you split into training set and test set. Okay, you guys have already told me why you are doing the split between the training set and the test set. Okay, that is very clear. After you have done this stress, what I do, suppose I have got age and salary as my data. Between age and salary, which is the dependent variable and which is the independent variable?
Age is independent and salary is dependent.
Hello?
Age is independent variable.
Age is the independent variable and the salary is my dependent variable, correct? Okay?
Yes, sir.
Now, I assume that I got 1000 records of this. So, I take and say 70% is my training set and 30% is my test set. Okay? Now, what I do, I take the 700 records, I feed my dependent variable and independent variable to the machine. I feed my independent variable and dependent variable, that is age and salary of the 700 records, I feed into the machine, and the machine gets trained, and based on the experience, it learns through experience, and it comes out with a pattern. Okay. Once it has come out with the pattern, then what I do is that I feed the independent variable to the model or the machine and come out with the predicted dependent variable, which is the salary. I feed the independent variable to the model. The model has already been trained. It has come out with some pattern, and it will do a prediction of the dependent variable, which is the salary. Then you will compare the predicted output. Okay. Now, this 700 records you have paid. Now, what I am doing, feeding the independent variable of what data? Of the test data. This I have not added here. I have got the 300 records of test data. Now, I have trained my model. I take the 300 records of the test data, the independent variables, I feed into the model, and I predict the dependent variable of this or the salary. Then I compare the predicted output with the actual salary of the test data. If my projected output of the predicted output is matching with my actual salary of the test data, that means my model is efficient. Okay, I can propose this model to my client. In any Python script or any script you see, machine learning scripts, these are the steps. You have to first do the data pre-processing steps, then you train the model, and next you evaluate the model, using the test set, right? Have you understood this flow? Anybody has any questions on this flow which I explained just now? Very, very important. If you understand this, then you can appreciate whatever coding you are writing or whatever script you are reading. Does anybody have any questions on this, what I explained?
No, sir.
No, sir, it's clear.
Great. So now, so this basically talks about the data workflow. Okay, very, very important. Now, what we'll do is we will go to the next slide. What are the various data pre-processing steps? Okay. So as I said, your first step is data pre-processing. Second is training the model. And third is evaluate the model efficiency using the test data. Okay. The first step, which is data pre-processing, the various steps within that is one, you import the libraries. Okay. So you have various libraries. There are three important libraries in Python. One is the NumPy, which is typically used for numeric processing. You have matplotlib, which is mainly used for graphical representation. And third is pandas, which is used for manipulating or basically the data set. So data set which you are going to use for process, the data which you are going to process to read that data. The data could be in a CSV format, it could be in a PDF format, it could be an Excel format. You have to use what is called the pandas library. So pandas has got various functions which helps to read the data. Okay. Once you have read the data, you have to identify which is the dependent variable. So dataset dot, this is an example of reading a CSV file, and you basically identify which is your independent variable and which is your dependent variable. So typically X is used as the independent variable and Y is used for dependent variable. And please note, if I'm using Python, these variables are case sensitive. So X and small x, capital and small have got different meanings. So they are case sensitive, right? Once you have done the data, importing the data set and identifying what is called the, you identify which are the independent variables and the dependent variables, then the next step is you have to decide or you have to define, look at the missing data and find out if there's any missing data or not. Okay. Now, typically what happens in the industry, if I have missing data, number one, what I will do is I'll go back to the client. Who is the owner of the data? Who has the ownership of the data? Anybody? Who owns the data? Can you tell me who owns the data? So it is a business or it is basically the business or the client who owns the data. You are not responsible for the data. So if there is some problem with the data, it is your first prerogative to go back to the client saying, hey, this data is wrong. I don't have this data. There's something wrong or something is missing. So the client's responsibility is to ensure that you get the right data. So if there is missing data, the client will give you the missing data. If he does not have, he will ask you to make some assumptions. He will ask you to make some assumptions and go ahead. So you will have to get the approval of the client before, once you have the assumptions ready, you decide, you discuss with the client, you all come to an agreement on the assumption that is made, and then you go ahead. Okay, the client may say you can remove one line of data. I don't require this because it's missing. Or the client may say you write your own function to come out with some missing data value. So depending on the agreement you have with the client, you decide what you have to do with the missing data. So when I come to the theory part, practice part, okay, I will show you, which I will start after the post lunch, after the break, the second session. I will show you how the missing data is taken care of. I will give you an example. But for now, just think that if there is a missing data, you have to ensure you have a concurrence with the client how to take care of the missing data, because the client is the owner of the data. He is responsible for the data. Any questions at this point of time? Does anybody have any questions? Okay. Am I audible, by the way? Okay, no, sir. Okay, great. Yeah. Sometimes when when it's totally blank, I really don't know whether I'm audible or not. So please acknowledge. I would appreciate all of you to please acknowledge by saying yes, no, something like that, please, because this is all online mode.
Sir, excuse me.
Yeah, sure. Please go ahead.
Sir, can you throw some light on the fifth step, splitting data into training and test set?
I'll
Did
come to
not
that.
get that.
I'll come to that. Let's go one by one. So missing data is clear. Okay. Now the fourth one is the categorization data. This is also very, very important. And I will explain to you what is data categorization. Now, what happens in machine learning algorithms? Machine learning does not understand text. They don't understand any text. They only understand binary values. Okay. And typically, you may have a set of data where you have the state field. And the state could be New York, Texas, and just give an example. Or let's say country, simple. India, US, Italy, simple, right? Simple example. Now, if this data were there as part of your input data, which your client has given you to come out with a machine learning model, you cannot use this data as is, because machine learning algorithms don't understand what is this India, what is US, what is Italy. So what you have to do as part of your data processing is number one, you have to convert this India, US, Italy into a serial number 0, 1, 2. If there are 4 countries, 0, 1, 2, 3. If there are 5 countries, 0, 1, 2, 3, 4, and so on. So depending on the number of countries, you create a sequential numbers starting from 0, right? Then what I do, I build an array. In this case, there are 3 countries. I will array of 3 variables. So what I'll do is, if it is India, US, Italy, I will probably say, if it is India, then I will say it is 100. If it is US, it will be 010. If it is Italy, it is 001. So what I have done, I've converted a country field having 3 values into an array of 3 values, where the presence of a 1 basically is a detection that that particular value exists. So when I say India 100, that means that is India. US could be 010 and Italy is 001. And these variables are called dummy variables. What you see are these 3 variables are called dummy variables. Now in machine learning algorithm, there are classes which takes care of this machine learning functions. This is called label encoder, which does the conversion into serial numbers, and the conversion into dummy variables is done by what is one hot encoder. Have you all understood the concept of data categorization? Any question on categorization? Anybody has any questions, or can I get a quick yes or no on the chat?
Yes, sir.
Ramakrishnan, what do you mean by identity matrix? Can you please talk, unmute and talk? Sometimes words may not be understood. I would appreciate if you could talk and explain to me.
Hello.
Yes, Ramakrishnan, yes, please.
Yes, sir. Good morning, sir.
Good morning.
Sir, you have chosen India, US, and Italy like 100,010,001.
Yes, sir.
It looks like 3 by 3 identity matrix. So why we are so specific to choose 100,010,001?
So that is how the function works, sir. This one hot encoder works in that way. Suppose you were, so I will tell you, so what will happen, I will tell you. When I show it to you, I'll show you. Suppose I have my data, which has got state, country, no, forget, country, income, age, and I say a person wants to buy a car, yes or no. I have a classification data. Okay, so I have got India, income is 20,000, age 30, and say yes. So what it does is this will get and I've got similar things here. Okay. So here I've got India, US, and I've got Italy here. Okay. Now what happens is once you do the data characterization, the data will be converted like this: 1, 0, 0, 20,000, 30, yes. Then you will have 0, 0, 1, 20,000, 30, yes, whatever, right? Similarly, 0, 0, 1, and so on. So when you're saying this matrix it is basically an array, not a matrix. It creates an array of 3 variables depending on the number of countries, and this is taken care by one hot encoder. You don't have to bother. Frankly, if you ask me, you don't have to bother. It will take care automatically, but you need to do this as part of your pre-processing step, and that is what is important. You just execute these 2 functions. I will show you in the screen. It will automatically take care of 100. You don't have to really care 100 whether it's India or US or Italy. It does that dummy variable array. It creates that array. Ramkishan, have I answered your question?
Yes, sir. Yes, sir. Why I'm asking this question is because it is connected with some linear algebra. Because I'm a background from mathematics, sir.
Yes, sir.
That's what I'm asking. It is a 3x3 identity matrix, and in linear algebra, it is treated as a standard normal basis. So, is there any connectivity this with taking this?
No, sir. No, sir. It is just creating an array of 3 values. Just remember that.
Okay, sir. Thank you, sir. Thank you.
It is just creating an array of 3 numbers, 3 values, because there are 3 country values. If you have been a 5 country value, create array of 5. That's as simple as that.
Right? Yes, sir. Thank you, sir. Thank you.
Okay. So this is called data categorization. So anybody has any questions on the data categorization? Anybody else other than Ramkrishnan, sir? Anybody has any questions? Okay. Then coming to the split. Okay. Once I have this data categorization done, is that I need to split into training set and test set. So somebody had a question on the training and test set. I will explain again. So what happens is, when you have data, you have to test whether the model is efficient. Now, if you were to feed or input all the 100% data to the model, you will not know whether the model is working perfectly or not. So you need to have a set of data which is not inputted to the model or the machine. That set of data which is separated out is called the test data. So once your model gets trained, your machine is trained based on the input training data, then you feed the test data to check whether the model is working as per the expectation. That's why you have to specifically divide into a training set and a test set. Have you understood, ma'am? I think who had called out this question, ma'am? Who had called out? I don't know the name, please.
Yes, sir. Understood.
It's clear, right? Okay. So very, very important. You need to have the split into a training test set. So what happens here? So I have X and Y, right? X is my independent variable. Y is my. So I will have X train, X test, Y train, and Y test. So I will create 4 variables, 2 for the dependent variables training and test data, and 2 for the test and 2 for the test set, that is dependent. One is for dependent training and test data and independent training and test data. So you will have 4 set of variables, right? Once you have done this, the last step which you have to do is called feature scaling. This is the last step for data pre-processing. So what were the steps earlier? You had started with the importing the libraries, importing the data set, identification of the independent and dependent variables. Fourth is taking care of missing data. Fifth is data categorization. Sixth is splitting the set into a training set and test set. And the last one is basically called feature scaling. Now, what is feature scaling? Typically, when I have age and salary, my age has got a specific range, say from 21 to 60. And my salary could be, say, from 10,000 rupees to 3 crores, 10 crores, 40 crores, 50 crores. Depending if I'm the CEO of a company, I may earn to that extent, right? If that be the case, if you see the age, the scale is 21 to 60, and my salary could be 10,000 to maybe 6 crores. Now, if I were to plot this, or if I want to do a comparative analysis between age and salary, which are in different scales, machine learning algorithm finds it very, very difficult to do a comparative analysis or to do some sort of analysis between these two features. So what machine learning algorithm does is that it uses a feature of feature scaling where wherever there is a difference ranges of values, scale of values, it tries to bring it to a common base scale. It tries to bring it to a common base scale so that the value becomes, typically the value will be become minus, it will be very small number, typically between -1 and +1. So when I execute this, you will come to know. But just try to understand when I'm using feature scaling, it is typically used when you have the various features in your data which have got different range of scale, and I need to use feature scaling to bring the data to a common base scale. And for this, the very standard function that is used in Python for bringing to a common base scale is called standard scaler. Standard scaler. Okay. And what does the standard scaler do? This is how it looks. This is the equation for standard scaler, which is x minus mean of x divided by standard deviation of x. Okay. So it does a calculation internally and tries to bring it down to one value, which is typically between -1 and 1. Okay. And this, besides standard scaler, there is another function which is used, which is called min max scaler, and that's also called the normalization, and it is x minus min x divided by max minus min x. Okay. Now typically you can use both of the in the industry, both are used, but I've mainly seen people using standard scaler. It again depends on the performance. It's again, there is no fast rule that you have to use standard scaler, min max scaler, but we have already seen, I've always seen that people use standard scaler. But the purpose of this feature scaling is, that's what is important, to bring your features which are in different scales to a common base scale. And this is what is called feature scaling. And when I show it to you on the screen, you will understand how it works. Okay. So any questions on feature scaling? Have you understood what is feature scaling? Any questions on feature scaling, please? Can I get a quick yes or no, please, on chat? First of all, am I audible?
Yes, sir, audible.
Okay. So Anshika, you're saying you're okay, clear. Saujanya, you're fine. Okay, great. Fine. So now we have understood what is data pre-processing. Okay. Now, can somebody explain to me what is a template? Can somebody explain to me what is a template? Can somebody explain to me what is a template? From your explanation, what do you mean by a template?
So something like a standard format that is already available for use.
Very good. So how do you explain it from machine learning, from a data pre-processing perspective? You're right. You're on the right direction. I mean, if you can be a bit clear, more elaborate, that will help.
We have data with this. We can fit it into the available format. So that will decrease the work to be done. We can save time.
Yes, save time. Correct, correct. But then what are you doing to save time? What are we doing to save time?
We make the data in the format that easily fit into the available template. The rest of the thing can be easily done. Like the rest of the framework will be supporting the given template.
So for example, I have my data pre-processing steps. So I started by importing my data set, importing my libraries, importing my data set. Then I had the identification of dependent variables. I took care of missing data, data categorization, then splitting the data and the feature scaling. So all this code can be predefined in my template. All this code can be predefined as part of my data pre-processing template. So as and when I get any new set of data, I can only play around with the data input I want to take, identification of dependent variables, or changing the parameters, but my main code is already there, so I can reuse the code. Okay, or if I want that there is no missing data, I can comment it. So the template is basically helps in reusing the code. That is why it is called a template, right? So data pre-processing template is essentially is basically how, so you can write all your code regarding right from missing importing the libraries to feature scaling in one particular file, and then you can reuse it as and when you want, right? Okay, I'm just bringing up Python Spider. Now, if you open Spider here, you see this is how the Spider looks. So typically, if you have Anaconda Navigator, which is one of the open source, if you install Anaconda Navigator, you will have Spider. You will also have Jupyter Notebook, which is another interactive development environment to write scripts. You also have R. R also is another language which is used for in data science. Now, what I'm going to do here, okay, what you see on the script here is on the left hand side here, this is where you're going to execute the script. Okay, this is where you're going to see your data. So you'll have my files here. What are the files? And the variable explorer. Variable explorer means whenever I'm going to execute a particular line of sentence, and if I want to see the output, I see it in the variable. And whenever I execute anything script, then I see it in the console. This is the console. Okay. Now what I'm going to do is I'm going to open one interesting file. I'm going to open a data pre-processing template. Central University Kerala, CUK, data pre-processing, and select folder. I go to files here. I will see something called data pre-processing template. sorry, data pre-processing template, right? Any Python file is suffixed by .py. .py file means it is a Python script. Now, let's take this example. Where is that example? Okay. Now, this is my data. Data.csv. You see the data.csv? Now you have country, age, salary, purchase, yes or no. Is this a regression data or is this a classification data? Anybody, is this a regression data or is this a classification data?
Regression.
It's a classification data.
Why we are saying it is a classification data? Which is your independent variable or sorry, dependent variable?
Purchased is my dependent variable.
Yeah. Can you please explain? Sorry, I lost the audio. Can you please explain? Hello, am I audible?
Yes, sir.
Now.
Okay.
Yes, sir. Audible.
Why this is called classification data?
Purchased is my dependent variable, and it contains the categorical data.
Correct. So my purchase is my dependent variable, and my country, age, salary is my independent variable. And since my purchase dependent variable is categorical, means it has got a fixed set of values. This is called classification data. Okay, so man, this is not regression. This is classification data. Okay, because in the case of regression, it would have been a continuous variable, continuous output, not a discrete output. Okay. Now, let us do one thing. First, I will do is I will import the libraries. This is my first. I'm doing only my data pre-processing step. So I'm importing my 3 libraries. So once I execute this, it is executed on the right bottom, and it comes to the next number. If there's an error, it will tell you the error there. Okay. I will import my data set. If I want to see my data set, I go to Variable Explorer. I go to the data set frame, and I see the values here: country, age, salary, and purchase, yes or no. Now, do you see some abnormality in this data? Do you see any abnormality in this data, or the data is fine? Whatever customer is giving me, I'm okay with this. I can build a model. Is my statement true?
There are missing values. There.
Correct. So there are missing values, which is represented by NaN. Okay. And if you see in the 4th row and 6th row, there's a missing salary and missing age. I go to the client. Client says, I don't have the data. You can come out with your own assumptions. Oh, you can write your own function. So what I do as I will talk to the client. I will tell the client, if I take the mean of I will take the mean of the other values and put it in the missing values. So I will take the mean of the salary of all the existing values, take the mean and put it in the NaN value. I will take the mean of all the ages and put it in the missing value. So what I will do, okay, before that, I will first identify which is my independent and which is my dependent variable. So if I go to X here, my independent variable is my country, age and salary, and my dependent variable is yes or no, whether it's buying the car or not. Okay. Using this function, what I'm doing is wherever the value is n, I'm not going to the code, please. I will use the mean function. Now see what it does. I'm going to execute this. And now if I see X, Do you see that the missing values are filled up with the mean? So my the salary, you see some 60,777 and this and the age you see 3877. Okay. This is one example how you can take care of missing data. Have you understood this, everybody? Very simple. There's nothing too much to explain. I've just showed you an example how you use a strategy called mean to replace the missing values. Do we have to do data categorization? Do we need to do data categorization? Anybody? Do you need to do data categorization?
Yes, sir.
Why do you have to do data categorization? Because you have a state field, no country field here. I told you, like if there is a text field, right? Machine learning algorithm doesn't understand text. You have to convert it into binary format. And we talked about label encoder, which converts into serial numbers, and one hot encoder, which converts into a serial array of dummy variables. Remember? Right? Now we will try to do that. See what happens. I am going to use label encoder and one hot encoder. Now what I will do, I will first do the label encoder. Okay. Now see. Now if I press X here, you see my country value has gone. I can see serial numbers 0, 1, 2 because there are 3 countries. Once I do this, I do the hot encoder. What does the one hot encoder do? And I see here, do you see that now instead of country, age and salary, you have got 3 dummy variables, age and salary, 100, 001, 010, whatever, depending on the country. Have you understood this? That's why I was trying to tell you that once you probably see it on the screen, you will be able to correlate with the theory portion that I covered. Have you now understood what this one hot encoder does and what label encoder does? Any questions on this? Okay, great. You guys have understood. Now, the next pre-processing step that I will do is splitting the data into training set and test set. As I said, you will have 4 variables: X train, X test, Y train, Y test. Okay, now if I execute this, now you see on the top, you had X, there were 10 records. Okay, so now I've done is, now if you see here, test size is 0.2, which means my test set is 20% and my training set is 80%. So in this case, if you see here, my X train is 8,5, that is 8 rows and 5 columns. Why 5 columns? Because we have 3 dummy variables, age and country. And similarly, X test is 2 records because it is 20%, 2 and 5. Similarly, Y is 10, Y train is 8 and Y test is 2. So I have split the records into 8 records of training set and 2 records of test set. Now, since I've got age and salary, now if I see X train, this is my 8 records of training set. If I do X test, is my 2 records of test set, independent variables. Now, since my age and salary are in different scale, I will use feature scaling to bring it to a common scale. So I will use the standard scaler. So let me use this. If I go back to X train, see the values of X train, you see it has got reduced from 40,000 to minus 0.77, 0.26. All the values have got changed. It has brought down to a common scale. Typically, you will probably do for the only age and salary. Here I've done it for all the features, all the values of the independent variable. Similarly, if I do X test, because I've done for X test as well, I will get anything varies between -2, -1 and so. Okay, it will bring it down to a common scale. So these are the various steps that you need to do as a part of data pre-processing, and once it is done, you start getting into the model training followed by model evaluation. Okay, so Till now, I have covered what is machine learning, what are the data preprocess, what is supervised learning, what is unsupervised learning. We also talked about what are the model workflow, very important. And then when we actually execute the scripts after this, in the second session, you will really appreciate why I've explained you this workflow. And then we followed out with the data preprocessing steps, right from importing the libraries, data sets, identifying the independent and dependent variables, then what is missing data, how do you take care of that? In this case, we show the mean. We saw data categorization, where you use label encoder and one-hot encoder to convert text into binary format, splitting the data set into training and test set, and finally feature scaling using standard scaler to bring it to a common scale. This is how you do the data preprocessing, which is prerequisite for model before you get into the training of the model. Any questions at this point of time? I'll pause for a minute before we wind up. Any questions, guys?
Yes, participants, you can respond. If you have any doubts, please ask.
Excuse me, sir.
Sure, please go ahead.
Yes. Sir, when we'll be splitting the data, is it always 20% and 80%? Or
no, it varies, ma'am. It depends on the volume of data. Typically, it is 70 to 30, 75, 25, 80, 20. This generally happens. But if you have very, very large volume of data, also I have seen 90, 10. Okay, but
so
majority of the data should be training. That's what is important.
okay, thank you, sir.
You cannot have 30% training and 70% test. Okay, that's not work.
Any other questions?
I hope I'm making sense. Are you guys are understanding what I'm saying? Is it easy to understand what I'm trying to explain?
Yes, sir. Very clear, sir.
Okay, if there are no
Okay,
questions, so we
Yes,
will
sir,
pause
no.
here. Sir, can we, is that okay? We can pause now. We'll again assemble at 11:30, sir.
Yes, sir. Yes. We'll meet again 11:30. We'll take a break, half an hour break.
Once we are back at 11:30, we will start with regression. We'll run some Python scripts, and then we will also run classification. Okay.
Okay, sir. Sure.
Okay. Thank you guys for your time. And I'll see you
Okay,
back at 11:30.
participants will take a half an hour break, and 11:30 will start again, second session. Okay. Please be in time. Okay. We'll take a break, half an hour. Thank you all.
Okay, sir.
Excuse me. Hello, am I audible? Sir, am I audible? Hello? Hello?
Yes, what you want?
Am I audible, sir? I just check my mic.
Audible, sir. Tell me. Sir, tell me. Hello. Hello. Hello, sir. Tell me. Audible.
Sir, am I audible, sir? Can somebody tell me I'm audible? I just want to test my mic if somebody is available. Okay, sir. Thank you.
Kumar sir.
Manas.
Shall we start, sir?
Yes, sir. Yes.
Aranjit sir is there.
Yes. We'll start.
So welcome back, guys. This is our second session today, and Mr. Aranjit Chowdhury is continuing in this session also. So, Aranjit sir, are you there? Sir?
Not responding?
Not responding, sir.
We'll wait just a minute.
Okay, fine.
Your mic is muted. Hello, sir.
Yes, sir.
Ranjit, sir.
Sir, can you call him?
Yeah, I will call. Just wait 1 or 2 minutes.
Sir, I'm coming. Sir, I have a minute. I'll just be back in a minute, sir.
Okay, sir. Okay, no problem. Meantime, Manas, anything you were to tell the participants? Participants, we have observed some of the participants are joining with the different names other than the registered name. So attendance issues will come. Okay. Please join with the registered name. If you joined with a different name, please inform to Manas or me. Okay. What is your registered name? What name you joined? That information you give it so that it is possible to update the attendance.
Yeah, good morning. I'm back, sir.
Yes, sir.
I'll share my screen.
Yes, sir. Yes, continue.
Is my screen visible?
Yes, sir. Visible. Continue.
Okay. So let me know, sir, when I can start, sir. I'll start.
No, sir. Now you can start.
Okay. Good morning. Welcome back, guys. So, so we covered the data pre-processing side. Just 1 minute. What is happening here? What is this nonsense here? Okay, so we cover the data pre-processing side, and now basically we'll cover the regression part, right? So in the regression, as I said, there are two types. One is a univariate regression and a multivariate regression, right? So we will cover an example of a univariate regression. We will show how the things work, and we'll go through the data pre-processing steps. We will go to evaluation, model training, and we'll go to model evaluation also. Okay. Now see how it works. Very interesting. I will just open the data set. Okay, so I will close this. And please don't. I mean, I'll be sending you this data set and Python scripts also, sir. I will send it to you so that you can pass it on to the participants. Okay, sir.
Okay, sir. Okay, sure.
So everything I'll give you along with the PPT. So now I'm going to regression. I'm going to simple linear regression, and I go to files, and I see something called simple linear regression.py. Okay. My data set is salary data.csv. This is my data set. Okay. So you have years of experience and salary. Very simple example. But for an understanding perspective, it is very, very important. Now you understand the flow. Okay. So now we know that the salary is the dependent variable. Okay. And the years of experience is the independent variable, right? We all know that, correct? Now, what we will do is we are going to execute the data pre-processing steps. So first of all, what I will do, I will go here. I will first import the libraries. Okay, so let me import the libraries. Correct. I will import the data set. If I want to see my data set, I go to my variable explorer and here is my data set. So yeah, I've got years of experience and salary, right? So this is the data which I'm getting from HR of a company. And as a data scientist, I need to basically come out with a model. Okay. Now I realize, obviously, based on this data, I can say that this has to be a regression model because my years of experience and salary are typically linear, right? So I will use a linear regression model in this case. So I will close this. I will also define what is my X independent variable and my dependent variable. So now if I see what is my dependent variable, independent variable, it is my years of experience, and what is my dependent variable is my age. Okay. Now, what are the various steps? Number one, pre-processing step, missing data. There is no missing data, so you don't have to do anything. Number two, data categorization. So what do we do for data categorization for this data? What do we use, one hot encoder or we use label encoder here? Hello. Can I get some answers from everybody, please? Where is that gone here? And am I audible, right? I think.
Yes, sir, you are audible.
Yes.
Yeah. So can I get some? Yeah. I would request all of you to participate. Let it be a wrong answer. Doesn't matter. Please participate. So do I have to do data categorization? Yes or no?
No, it is not required, I think.
No.
Perfect. Yeah. So please, that's right, because there is no text field, right?
Right.
So
Yes.
there is no text field here. So I don't have to do data characterization. Very nice. What about splitting of data?
Have to do.
Splitting of data is a must, whether you like it or not, right?
Yes.
You
Yes.
have to split the data. So I will split the data into training set and test set. So I have got total 30 records. Out of it, 10 records is test set, 20 records is training set, because my 1/3 is my test size. I've used 1/3 instead of 30% just for calculation because it's 30 records, right? So easy for calculation perspective. What about feature scaling? Is feature scaling required? Do we require feature scaling or no?
Not sure, sir.
See, we have years of experience and year salary, right? Again, years of experience will have typical from 1 to 35, 40 years, right?
Yes.
While your salary will still have maybe can have a different scale, na? So you need to do feature scaling.
Okay.
I mean, years of experience is as good as age, right? So if age and salary are going to do feature scaling, years of experience also you have to do feature scaling because they are in different scales. Now, in the case of linear regression, why I have commented the code, you see I've commented it's in green color, is because the linear regression algorithm itself takes care of feature scaling. So you don't have to do explicit coding here. You don't have to do explicit coding here, and that is why here you have seen that it is commented. Okay. So what I will do is, now my model is ready for training. So what I do, I go here. From here, I'm using the linear regression model algorithm. I'm giving X train and Y train, both independent and dependent variable, as an input for training. So I will select this. So my model is trained. Once my model is trained, as I told you during the workflow, I will feed the independent variable of the test data. This is my independent variable of the test data. This is my prediction function, and ypred is the predicted dependent variable of the test data. Ypred is the predicted value of the test data. So if I select this, now how do I compare? So what do I now? Ypred I will compare with what? Tell me. Ypred I will compare with what? Ypred I will compare
White
with
train.
what?
White
Why?
train. Train.
Why train?
Why?
Anybody else?
With
Why?
the actual values. With the actual values.
Yeah, but what is that? Why train? Why test? What?
Y test.
Why test? Perfect. Ma'am, why train? You have already trained the model, no? You cannot use that training for testing.
Okay. 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 Sir.
So you will take X test, you will predict Y based on the learning the model has gone through, and then you will compare Y pred with Y test. Now, how will you compare? There are various ways of doing it. What I can do physically, I can go to Variable Explorer. I can select Y pred, and I can select Y test. So I can do a sort of a manual comparison between Y test, which is my actual test data, and Y pred, which is my predicted data coming out of the model. So this gives you a fair idea how far away is your predicted data from the actual data, right? While this is sort of a manual process and very tedious because of a various volume of records, it will not make sense. So the another way of doing it is using the matplotlib. Using the matplotlib, I will run this for the training set. See what I'm going to use the training set. See what is going to happen. This line, this is your salary, this is your age, or sorry, years of experience. This blue line is coming from the predicted line. It is coming from the model. The model is predicting for this age, this is the salary. For this age, this is the salary. This is the line which is the predicted line coming out of the model. And these dots are the training data set, actual data set, actual training data. And if you see that there are some points away from this, there are some away from this, there are some away from this, and so on. So your data, this model, when it was trained, is okay. I mean, it has realistically give you a good sort of output because there has not been any outliers. I mean, you have not got any data somewhere here, somewhere here, somewhere here. It has been pretty close to the predicted line, right? If there have been any outliers, then obviously your data pre-processing also must have been incorrect. Okay, since we have already taken care of outliers or any data which is out of range, as part of your data preparation phase, you will have a sort of a very clean data where you have trained the machine, right? Similar thing I will do with test data. So I will run this with test data. Now you see the test data is working very well. The predicted value, the model has predicted from the model, it has predicted pretty accurately as compared to the actual test data. See, if my actual test data red dots is very close to my predicted line. So this model is pretty good. Now, how do you measure the model efficiency? Obviously, you can do this using this verbally. You can see that it is a one of the preferred models for this particular set of data. Another thing which is used today for regression model, okay, let me just explain you this very important line. If you remember, this was the predicted line which I showed you, and this was the dots. This predicted line is y predicted. We generally denote it y caret, and yi is the actual. So your main aim is to reduce the gap between yi and y predict, or I would say sum of yi and y predict the whole square should be minimum. This equation in machine learning algorithm, this is how the regression model works, is called ordinary least squares or cost function. The main aim of your model is to minimize the cost function or to minimize the ordinary least squares. Okay, that is the sum of yi minus y predict the whole square should be minimum. Once you have understood this, this is the equation to find out the efficiency of a regression model. The equation is r square equal to 1 minus sum of the square residual divided by the sum of the square total. What is sum of the square residual? Sum of yi minus y predict the whole square, which is the least squares, ordinary least squares, or is also called the mean square error. There are various terms you can use. So if my model has to be efficient, my sum of yi minus y predict the whole square has to be minimum, or it has to be close to 0. If SS residual is close to 0, then 1 minus SS residual by S total will be close to 1. So my way to measure the efficiency of a regression model is what is using R square. And for the model to be most efficient, my R square has to be close to 1. Is this clear to all of you, what I said? Any questions here? Anybody has any questions?
No.
Sir, could you kindly explain that random state equal to 0, this parameter, what is the function of that?
Random state of 0 is it uses an internal function to split which sort of how the data will be split between training and test set. So which I mean, it uses an internal function, a random state. Maybe it will say maybe this 10 records will be training set, this 20 records will be test set. So it defines, so there is a random state 0, 42. It's an internal function where it will internally decide which set, which out of 30 will be training set, which out of 30 will be test set, that way. So you can use different random states. So there are some parameter functions which are available.
Okay. Thank you, sir.
Have you guys understood? See that for the main purpose of that model workflow was to tell you the flow, and now if you want to bring that concept into this actual code, you'll now be able to really appreciate why we are doing this, right? So now after doing the data pre-processing data model, we have evaluated the model using the YPRED. Now we have also calculated the model efficiency. Now how do I calculate the model efficiency? So what I will do, I showed you the function. I will open another file, simple linear regression model efficiency. Okay. Now what I've done here, it is the same thing. Only thing I've added one more library called R2 score class, which I'm importing. I will execute everything up to the end except for the last line. Okay. So this I've already done. So I'm just executing the same thing. Now this is where I calculate the R2 score. So my R2 score, where I'm taking Y-test and YPRED as my parameters, is 0.97, which is 97%. So anything above 90 or even 95% is supposed to be the recommended model to the client. Okay, so using the R square, I have calculated the model efficiency. Any questions on this? Don't worry, I'll be sending you this scripts. You can test it at your leisure time, but just understand the concept here. Okay, so now we have covered simple linear regression. Now let's try to cover multiple linear regression. Okay, multiple linear regression. Okay, now see what we are going to do. So I will close this. I will change the folder to multiple linear regression. So let me open multiple linear regression. And I will open a file called multiple regression.py. Where is it called? Yeah. Okay. Now let me open this file. This is my data file. So can anybody tell me which is your independent variable and which is your dependent variable?
Profit is a dependent.
Correct. Profit is my dependent variable because it depends. This is what I actually explained to you as an example before the in the first half, where my profit is dependent on the R&D spend. Profit is dependent on the administration spend. Profit is based on the marketing spend, and obviously which state my company is in or located in, right? So my profit is an dependent variable and the others are the independent variables. And since this is profit is a continuous variable, this is a multiple regression data, right? Now what I will do, I will do the same steps. I will import. Again, the concept is absolutely the same. I import my data sets. I import my libraries. I import the data set. I take X and Y. What is X? X is my 4 fields and Y is my profit. Come to data pre-processing. Okay. Now if I look at this file, assuming there is no missing data, there is no problem. What about data categorization? Is it required?
Yes, required.
Why?
Because state is there. State is a string.
Correct.
So
Correct. So state is a text field. So you need to do data categorization to convert this into a binary. Now what I do is I again go back. This is where I use one hot encoder and this coder. I do this. Now if I go back and feed X, you see here, since there are 3 countries, and see the interesting part, the state which was the 4th field in the actual input file, when you do the data categorization, the dummy variables are moved to the left. The dummy variables starts with the dummy variable. That way I can put it. So instead of the country which was here, now it has come here, replaced, and you have replaced the country value by 3 dummy variables because there are 3 country values. And after that, you have the R&D spend, whatever the marketing spend, and the third is administration spend, whatever that 3 independent variables, right? Okay. What about splitting? Yes, you have to do splitting anyways. So there is no mix here. So I'm talking of 80% test training set, and because test size is 0.2 means test set is 20% and training set is 80%. Is feature scaling required? Is feature scaling required for this data? Can I get some answers?
Participants respond, say yes or no.
Yes.
Why? If you say yes, I will ask why. If you say no, also I will ask why. So please have the why answer also, please. You're right, but why? You're right, but why?
ranges are different.
Correct. My
Different
profit can be in different range. My marketing spend can be in different range. My administrative spend can be in different range, right? So wherever we are uncertain of the ranges or there could be different values, always you should do feature scaling. And as I said, since we're still using linear regression algorithm, we have commented the code because feature scaling is inbuilt in the algorithm itself. Okay. So I will again do the same thing. Again, the same thing. I will do the linear regression. Here, instead of one independent variable, I am feeding multiple independent variables. And I can do a prediction here. Okay. So similarly, what I done earlier, I can do a y-test y-plate comparison either using my R-square, or I can do a comparison using the matplotlib, or I can do a manual visible sort of a thing where I can compare y-test and y-plate through my variable explorer. Okay, so the concept of multiple regression, we are using the same regression algorithm. Only difference is you have got multiple independent variables and a single. Now, have you guys gone through the statistical portion in the first 2 days? Have you covered p-value? Have you covered p-value in your mathematics foundation session?
Yes, sir.
You have covered p-value. So what is p-value? Anybody can explain?
It is covered in Pearson correlation. I think.
It is covered in what? Sorry?
The Pearson correlation. Correlation concept that it's covered.
Okay.
Correlation.
Fine. I will give an example how I'm giving. Yeah, sorry. Somebody was saying something. Sorry.
So continue.
Okay. So let me give you this example so that, okay. Now, one of the very important things that happens today is that as a CEO of a company, that we are having only 3 independent variables here. Imagine there are 50 variables which decide the profit of a company. So as the CEO of a company, I need to know which variable has the highest impact on my profit. Which variable has got the highest impact of the profit? And that is where you use a concept of a null and the alternate hypothesis. What happens is that there is something called a p-value. A p-value. Okay. P-value, when null hypothesis means that the variable has no impact on the dependent variable. Alternate hypothesis says that variable has impact on the dependent variable, which is the profit. Okay. Now, if there is a p-value which is there for every feature, okay, and that p-value, there is a method to do that. Once you calculate the p-value, there is something called a significant level, which is typically 0.05 or 5%. Okay, where 5% is the significant level. Okay, that means we are trying to achieve. That means 5% is the error rate, 95% is the accuracy rate. So what statistics says that if my p-value is greater than the significant level, which means null hypothesis is applicable. That means if my p-value is greater than the significant level, that particular variable has no impact on the profit. So I eliminate that particular variable. So this is called, this process is called backward elimination. So what I'm doing, if I've got 50 features, I go through all the 50 features, I calculate the p-value, I compare it with the significant level, I eliminate feature one at a time. I don't do all at a time. So I take 50 features, I calculate the p-value, taking the p-value which is the highest, which is more than 0.05, I eliminate that feature. Then I take the remaining 49, I recalculate the p-value, and again see which p-value is highest, greater than 0.05, eliminate. So I go on eliminating the those features where the alternate hypothesis, the null hypothesis is applicable. That means the variable has no impact, and take that feature which has got the lowest p-value. That's where the alternate hypothesis will be valid. And this is where this p-value becomes very, very important when you're using a multiple regression and your problem statement is, how do I understand which of these variables is having the highest impact on my dependent variable? Did I make sense what I said? Any questions? Any questions from anybody, please?
Clear, sir.
So one question.
Sure, sure. Go ahead.
So can you please explain exactly like how will we eliminate, like if the p-value is greater?
Yeah. So suppose I got 3 variables here, A, B, C. Okay. Let's say there are 5 features. Okay. I calculate the p-value. This is 0.06. Okay. So this is say 0.08, 0.04, 0.03, and 0.09. So if this be the case, I will take the p-value, which is the highest. So which is the highest? 0.09. And this is anyway more than 0.05, right? If it is more than 0.05, eliminate this. Then I take A, B, C, and D. Recalculate the p-value. Again, it will not be the same p-value because it depends on various. So again, you will have different set of p-values. Again, find out which is the highest p-value, which is greater than 0.05, eliminate that. So you will go on the process of elimination. So later maybe you will come B, C, D, or you will have then C, D, and then maybe only C. I'm just giving an example. That's I'm throwing an example here. So that means this D feature has the highest impact on the dependent variable. Similarly, in this case, we are trying to find out between the R&D expense, admin expense, and marketing expense, which has got the highest impact. So that as a strategist, I as the CEO of a company can say that, okay, I need to focus more on the R&D to increase my profit. Does it make sense, ma'am, who has asked this question? Have you understood?
Yes, sir. If the p-value gets less than 0.05, so whatever be it for 2 variables or 3 variables, please stop there, right?
Yes, typically, yes, you will have, I mean, you will have one with the lowest p-value, right? Even if the p-value is 0.05, 0.02, 0.01, you will have the one with the lowest p-value. You pick up that, which is the highest significance.
Okay, sir.
Because you want to reduce the error rate, right? So, yeah. Okay, so is this clear? I mean, this is very important, and good at least you know what is the p-value. This I wanted to just make sure that you had covered that as part of your mathematical foundation. And I always tell my students or my faculties, please spend some time on statistics. If you want to take machine learning as a subject with your students or as part of your professional, as a PhD or whatever you want to do, please have your statistics foundations clear and strong. If you're not able to do that, then it becomes a bit difficult. Understanding this p-value, understanding coefficient of variance, understanding standard deviation, understanding variance, understanding all these terms are very, very important. What is outlier? What is interquartile range? So many of these colleges where I'm interacting, I always propose to them when I'm doing workshops. For example, I don't know whether you've heard of Symbiosis Institute in Pune. So they were one of the first colleges who said, okay, they'll first do statistics. They will have a workshop on statistics with us. Then they will do machine learning. So I think you should always remember one thing. If you want to teach machine learning to your students, unfortunately, statistics is not there as part of the curriculum, but you have to make sure that you ask your students to get this foundation clear. Okay. So now have you understood the regression part, the linear regression, where we talked about univariate regression, multivariate regression, and we also talked about backward elimination, how to find out the way to basically to find out which variable has the highest impact on the dependent variable, in which this case is the profit. Any questions on regression before I go to classification? Any questions?
Sir, can I add one point here?
Please do go ahead.
Yeah. Sir, you said the variable which has the least p-value would be ultimately selected.
Correct.
Apart from looking at this least p-value, we should also simultaneously look at what is happening to R-square value. The model with number of independent variables, let's say 3 independent variables which have p-value less than 0.05, if that model has highest R-square value, normally all 3 are retained.
Okay. So, okay. But then you ask, okay. So basically what happens, yes. So there is something called an alternate R-square, which is used for multiple regression model, where you basically use the number of features. But typically I have seen that, again, if you are asked, okay, now you have a model efficiency, you're right. If you have a model efficiency, and if I see that a particular, but then you have to take a call as to whether you should retain the, so what is your experience? What is your feeling? How do you take care of that?
Now, suppose we retain, let's say, after all three independent variables have p-value less than 0.05, and therefore all 3 are significant contributors to dependent variable.
Okay.
Whether to retain all 3 or eliminate some would depend on whether your R-square value would be highest with all 3 or highest with 2 or highest with only 1.
Yeah, but
so we also look at the model efficiency in terms of R-square.
Model efficiency certainly you use by R-square, but here the purpose is, see, the purpose here is different, right? The purpose here we are trying to find out which has got, see, all the 3 may be significant. So it is basically for me to strategize how do I want to focus on my R&D expense or whichever the 3 variables to have basically to see how I can maximize or minimize my profit in this case. Okay. But the model efficiency will tell you whether with this set of data, this algorithm that we are using is suitable or not. The algorithm which I'm using, see, tomorrow, I mean, if this algorithm doesn't give me a high R-square, okay, that means I'll have to relook at it, right? So you have to look at one R-square is more formed to decide whether that model is appropriate for this set of data. And what I'm talking about, this backward elimination is to identify which variable has impact so that I can take some decision on, not from a model efficiency perspective, from a strategy perspective, what should I do?
Yeah, okay, fine. That's, yeah. If you are not looking at the model efficiency, but looking at the variable which has highest contribution to the dependent
contributor to the independent variable. That is right. That is right. But that's a good point. I mean, obviously, if there are 3 variables which are having less than 0.05, 3 are equally important. Okay, but your model efficiency again will, depending on those formula, yes, you can always calculate and see what is the model efficiency, but that model efficiency you will typically do with your full set of data, not just the elimination of 3 variables, right? You will, whatever the, with 50 features you have, you will find out whether the model is apt for the complete 50 features of data and not those 3 features, because that is just an impact on your dependent variable.
Yeah, correct. Yes.
Okay.
Yes.
Hello.
Yeah, please go ahead.
Sir, I'm Ramakrishnan, sir.
Yes, Ramakrishnan. Yeah, please go ahead.
Sir, actually, we are doing the linear regression model. It's really good. But I think indirectly...
Sir, one small intervention. Your voice is very feeble.
Sir, am I audible now?
Yeah, you're audible. At least I can hear, sir. No problem. Please go ahead. Please.
Yes, sir. Yes, sir. So the thing is, I think regression model is connected with the correlation coefficient between the variables.
Correct.
Indirectly, I think in this particular Python programming, it is calculated, sir, the correlation coefficients.
So one of the things which generally you have to do, there is something called an EDA, exploratory data analysis. So when you actually start doing your coding, right, you have to do an EDA where you calculate. There are some ways where you can calculate the covariance or the correlation matrix, where it says that whether the two variables are dependent on each other or they're independent of each other. So those are the things which you anyway have to do as part of your correlation. And there are features like heat maps. I don't know whether you've heard of heat maps. And there are some libraries called Seaborn, which helps you to create an heat map where it tells you that for the different features, what is the correlation between the various features. Okay, so that way also you can know how your data is moving, whether these two data are independent of each other, they're dependent on each other, or they're not all. I mean, there is either it could be in one direction, that is in which is greater than 0, or it could be in negative direction where the correlation coefficient is less than 1, less than 0, or if it is 0 means it is both are not dependent on each other. So you have a correlation coefficient you can calculate.
Yes, sir.
Okay, so there are various
E-Bond, sir, the library.
Seaborn, SEABORNE, Seaborn, and the graph which you get is called the heat map, HEATMAP, heat map. Okay,
yes,
there are various graphs. Yeah. Anything else? Anybody has any questions? It's good we are interacting. Please ask. I mean, I'll be happy to answer. So can we go ahead with classification? All of us, can we go ahead with classification? Okay, so let us go ahead with classification. So I will share you this PPT, don't worry. Okay, so you will have this PPT with you. I will send it to sir tomorrow morning. Okay, now what is classification? Now, as I said, the dependent variable will be a labeled fixed set of values, right? Yeah, somebody had a question, sorry. Somebody had a question. If somebody is not speaking, can you go on mute?
No, I think they are putting it on the chat box apart from PPTs.
Oh,
Please share the script also. That is what they are putting in the chat box.
Okay, let me put. Yes, Poonam, you will get everything. Don't worry. I will share the script. I will share the data set, and I will share the PPT also. You'll get everything. Don't worry. So you guys can practice at your own convenience. Okay, so let's go back to classification.
Sir, I have one question.
Please go
in
ahead.
multiple linear regression, you
Yes, sir.
identified which one is a more impact on the dependent variable. So then multiple is converted into linear regression. No? You are choosing only single variable, which is more impact.
Yeah, that is just okay. This is just to basically find out the one which is having the highest impact. That's it.
Okay,
there is something called principal component analysis, PCA, where you do a feature extraction where out of the 7 variables you eliminate the variables and see the one which is having the highest covariance. Okay, that is called a feature. It is called a feature extraction method, and this is called feature elimination.
Okay, sir, I understand up to that. You selected one. After that, what is the next step?
No, that is just for you to strategize as to what as a CEO what you need to do. Which is the particular feature you need to focus on. That's the only thing.
My question
is
in the case of linear regression, you draw a line, okay, using the dependent variable and independent variable. Here, more dependent variables are there. One dependent variable, more independent variables are there. No? Multiple linear regression.
Correct. So you basically use the R-square method to find the efficiency. You don't use the because in linear regression will not work, right? So you will use the R-square method to find out the efficiency.
That's okay. Prediction part not completed, na? Multilinear regression.
So multilinear prediction. So multilinear prediction, you did a Y predict, right? You use the same concept. You fed all the independent variables. You fed the dependent variable, train the model, right? Then what you did a Y pred. and then in the Y-pred you fed the X test. X test means all the independent variables, and then you're comparing Y-pred with Y actuals.
No, that's okay. You completed up to which variable is the highest impact on the dependent variables.
These are two different things. So one is the efficiency of the model, which I didn't do this. I didn't continue because I had already shown it as part of the simple linear regression model.
That's only my question. So you up to that you stopped. That I am thinking.
Correct. I want to stop because the process is the same, because you will still calculate the R square, you will follow. But I wanted to introduce this concept of backward elimination because that is very important. And since you're already covered p-value as part of a mathematical foundation course, I thought let me just cover that. And this is very important. That is the only thing. Otherwise, I could have covered, I would have more time than I could have actually run the entire script. In fact, I would have also run this. In fact, I'll give you the script, you run it and see.
Yeah. Just we have to change that equation. That's only. We have to include more variables.
That's it. Yeah.
That's it. Okay, sir. Continue.
Okay. Thank you. So coming to the classification, right? Typically, as I said, you will have the dependent variable which has got a fixed set of values. Now, if you see here, you have got, this is a standard vertebrate data set. This is any coaching that you do, they'll always start with this data set. So you have name, body temperature, skin cover, aquatic, gives birth or not, has legs, so on. All these parameters, features will decide whether it's a mammal, reptile, fish, or so on. So these are the discrete set of variables or the class labels, which is why this is called the dependent variable. Okay. What I'm going to cover today is there are three important. One is the logistic regression. Second is decision tree. And third is the random forest. There are various others like the support vector matrix, naive Bayes theorem. There are so many of algorithms which are available today for classification. But for today's session, I will cover this three. Now in logistic regression, let me again go back to my script. I close this. I open this. I go back, regression, classification, right? In the classification, I've got logistic regression. I say select folder. Okay, I open logistic regression.py. And what is my data set? I open my data set is this one. This we have already covered. I have got user ID, gender, age, estimated salary, and purchase yes or no. Okay, so this is a user who logs into the portal, automotive car portal. He enters his profile details and then he selects or ticks marks whether he's going to buy a brand of car or not, right? So I collect all this data and I give it to a data scientist, and who will be able to predict a model which will give me close to the actual data, right? So in this case, your purchase yes or no is going to purchase a car or not is going to be my dependent variable. User ID has no meaning, right? It's just a login ID. So it is going to be, it has no meaning or it has no impact on the analysis part. So we can omit that when I'm deciding which is the independent variable. The client also says that I don't care for the gender. I don't care for the sex. Okay. What I am important to know is the age and the estimated salary. So for this particular exercise that I'm going to do, I will take my independent variable as age and salary, and purchase yes or no is going to be my dependent variable. Okay. So I will open this logistic regression. Again, the steps are the same. Data pre-processing, train the model, evaluate the model. That is going to be your steps. So I will import the libraries. Okay. Then I will import the data set. Okay. So I'm only going to take age and salary as my independent variable and salary as my. So if I see X here, my X is what? Age and salary, and my Y is 0 and 1. Where is going to 0 means he's not going to buy the car. 1 is going to buy the car. Okay. Now with this set of data, I'm assuming there is no missing data, so that is okay. What about data categorization? Do you need to do data categorization? Do you need to do the data categorization?
Yes, sir. Yes, sir. For gender.
Yes.
Yes. So ideally, you would have done data categorization for gender, but since I'm not going to use gender as part of my independent variable, I can omit it. Right? Because I'm not doing analysis based on the gender. I'm doing analysis only between age and salary. So I can omit the data categorization. Is that clear? Why I'm omitting it? Okay.
Yes.
Yeah. What about, okay, splitting, so you have to do. So I will split the data. Okay. After splitting the data, so I've got 25% test data and 75% training data. So if I go to a variable explorer, so out of 400 records, there are 100 records of training data, okay, 100 of test data and 300 of training record, because 75% is training and 100% and 25% is test. Okay. Do I need to do feature scaling? Do I need to do feature scaling? Anybody?
One response is there, yes.
Sir, I think in some of the cases it is basically required, because some of the cases the values are too high, and so the scaling is
Correct.
required in
So,
these cases.
yeah, you have agent salary. Now we have already done it so many times, right? So you have to do feature scaling in this case, right? Because again, age and salary are in different scales, right? Now, as against in linear regression, where the feature scaling was part of the algorithm, in this case, you have to explicitly do feature scaling. So now, if I do xtrain here, and I do x test, I got 300 and 100 records, right? Now, I'm going to use standard scaler, and I'm going to do this for x test and xtrain. If I do xtrain again, see the values has come down somewhere between -1, 1, 0.53, 2.33, so on. Similarly, if I do x test, is again very small values, right? So I have done the feature scaling, and now I have completed my data pre-processing steps. So next step I will do is, again, same equation. I'm going to use logistic regression class. I'm going to feed the input xtrain and ytrain, and I will train the model. Okay, so model is trained, and now I calculate the y predict. What will be the possible values of y predict?
Zero or one.
Yeah, so what possible values of y predict also will be 0 and 1, right? And then again, I will compare y predict with y test. Simple as that, right? Now, so one is I can do a y test and y pred. So I then take y pred, y test, and do a sort of a manual sort of a thing. Okay, this is y test, and this is actual data. This is a predicted data, and I see where there is a difference, right? Okay. Other way of doing it is using matplotlib. So what I can do, I can select this. Okay. Matplotlib, if you see here, this is a line which is called the prediction boundary. It's a linear boundary. That's why it's called logistic regression. It's a linear. And this line, what you see on the left-hand side is the predicted value of 0. And what you see on the green is the predicted value of 1. Okay. And what you see, these red dots means my actual value and my predicted value is same. And if you see the green dots in green, the actual value and predicted value is same. Okay. Now, before I explain into more details, I will explain you a concept of confusion matrix. Just as we had R square to find out the efficiency of a regression model, we use confusion matrix to measure the efficiency of a classification model. Okay. Now I will explain you how it is. If you see the screen on the top in the columns here or this horizontal, you have Y predict. Y predict is your predicted value coming out of the model, and Y actuals is the actual value which is coming out of the model, which is the again dependent variable, right? The values could be either 0 and 1. So he's not going to buy the car, going to buy the car, not going to buy the car, buy the car. Okay. Assuming that I've got 100 samples of test data, I have seen there are 35 cases where the predicted value is 0, actual value is 0. That means I predicted that he is going to not buy the car, and actually he has not bought the car. So that is perfect. My model is working fine. There are 50 cases where my predicted value is 1. That means he is going to buy the car, and actually also is going to buy the car. So the model is perfectly working as per my requirement. Now look at the remaining 15. There are 5 cases where I have predicted that he's going to buy the car, but he has not bought the car. There is some error. And there are 10 cases where he is predicted is not going to buy the car, but actually has bought the car. Okay. Now let me translate this into a more familiar, which I generally explain is using a cancer patient. I'm saying 0 means the person does not have cancer. That means cancer is benign, and 1 means he is having cancer that is more malignant, right? Okay. Now there are 35 cases where the person has predicted that he's not going to have a cancer, and he's actually also does not have cancer. There are 50 cases where he's going to have cancer, and actually also he has cancer. Okay. Now this, what is called, it is true positive, because he has predicted he has cancer and actually also he has got cancer. This is true negative. He has predicted he does not have cancer and actually also does not have cancer. Look at this. So this is called true positive. This is called true negative. Look at this. There are 5 cases where he has got cancer predicted, but actually he does not have cancer. There's an error, but is less severe error, because he is not cancer, but the prediction that he did not have cancer. Prediction that he has cancer, but actually he did not have cancer, right? This is called a type 1 error. This is called a type 1 error. Look at this 10. He has predicted that he is not going to have cancer, but actually he has got cancer. This is the most severe issue. If my model is predicting that he's not going to have cancer, but actually he has cancer, there's something wrong. It's a big thing. It's a big error as far as the model is concerned. Okay. So this is called type 2 error, or also it is called the false negative. Okay. So when you calculate the efficiency of the model, we'd use one is the accuracy rate. So in this case, the accuracy is, of course, 85%, and the error rate is 15%. So your main aim is to maximize the accuracy rate and minimize the error rate. Have you understood this concept of confusion matrix? Is it clear to all of you? Any questions?
Yes, sir.
Please go ahead. Yes, yes, Anshika, please go ahead. Yeah, Anshika,
So
right?
this way type, yes, sir.
Yeah. Tell me.
So this way type 2 error will be more dangerous, right?
Type 2 error is more dangerous. Correct. That's why it is red here. If you see here. Because you cannot have a situation where your predictor does not have cancer, but actually has cancer.
Yes.
So you will have to eliminate type 2 error for sure, plus also type 1 error. Okay.
So both the errors are relative. So if we minimize one, does it mean that we'll have to increase the other error? Like they are relative to each other, no?
No, they are how they are related to each other. They are different. They are different sample records, right? You have got 100 records totally, and you have found there are 5 records where you have type 1 error, and there are 10 records which are having type 2 error. That means your model doesn't work well. This specific, if your model is going to give this error, where your accuracy is less than 90% or 95%, that means there's something wrong. So you need to try some other models. Okay, you need to try out a model which will give you a higher accuracy. So typically what happens in industry, you will have the same set of data which I will show. You will run various types of models. You will run logistic regression. You will probably run SVM. You will run this one. You will run decision trees. You will run random forest and see the one which is giving you the highest model, highest efficiency, confusion rate, or highest accuracy.
Okay.
Any other question? Am I clear? Anybody has any other question, please?
Sir, is there any way to know beforehand that which model is going to be the best for my data set?
It comes to experience, sir.
Okay.
It doesn't. I cannot say whether this data this decision tree will work out well. That is why you need to try out various options, sir. And typically, I have seen that. Have you heard of underfitting and overfitting? Anybody?
Yes, sir.
What is underfitting? Please go ahead. Don't worry. If it is wrong, also it's fine. We're all learning. What is your understanding of underfitting and what is your understanding of overfitting? Anybody?
So as far as I remember, underfitting, I think it's when the predicted values are lesser than the actual value. Or maybe we use a lesser number of independent variables.
No, not the case. Anybody else? So when you have underfitting, that means your training errors are high. That means when you did the prediction for the training of the model, when you train the model, the predicted value and the actual value for the training data was very high. Similarly, for the test data, the errors were very high. In the case of just fitting, means you have a case where the model is perfectly good, like just as we saw the linear regression, where you got an efficiency or an R-square score of 97%, right? And overfitting, what happens? Your training data, it has worked well with the training data, but it doesn't work well with your test data. So the errors with training is minimum, but your errors with test data is high. Okay, so you have to look at ways where you can eliminate overfitting or underfitting, overfitting and underfitting. Okay, so there are various ways to do that. I think so. Generally, when I go to decision trees, I will typically find an overfitting errors, and that is why to take care of this overfitting issue, it is always recommended to use random forest. I'll come to that. What is decision in random forest? But just wanted to let you get an insight of what is underfitting and what is overfitting. Okay. So is this clear about the confusion matrix? Have you guys understood what is confusion matrix? Okay. Having said that, now let us go to this. In my confusion matrix, I will give y-test and y-pred as my parameters. So what is my accuracy here? What is my accuracy?
%89%.
Perfect. So my accuracy is 89%, right? Now, if I want to represent this in a graph, that is what I'm showing you. So you will see that there are red points in red, green points in green. There are some red points in green and some green points in red. So these are the type 1, type 2 errors. Similarly, if I were to do this on my test set, this is how it will look. And if you count, so there are again some greens in red and reds in green. So if you count all these, right, will be total 11. If you saw, we saw that 11, right? 89%. That means there were 11 type 1 and type 2 errors. So these are the 11 ones. There are green in red and red in green. So this is how you can also, using matplotlib, of course, confusion matrix, to find out how your model is working graphically. So any questions on logistic regression? Okay. Let us do one small quiz. Okay. Till now, whatever we have understood, let us have a quick glance. Can somebody tell me which are the, of course, I have not covered this, but let me see based on your experience. The first question, which are the examples of machine learning applications?
Participants, please respond.
So chatbot.
Sir, prediction model,
So chatbot.
fraud
Chatbot.
detection.
Chatbot. Okay.
Fraud detection.
Prediction model.
So prediction model is not an application, it's a model, right? To predict the future data, maybe based on past, maybe a time series analysis and all that. Fraud detection is an application.
Yes.
Okay, it's today in banks, you have machine learning algorithms which can identify whether a transaction is a fraud transaction or it is a normal transaction. Google search works on the principle of machine learning. When you do a Google search, there is a machine learning algorithm which automatically gives you a set of intelligent searches based on your past searches, right? Chatbot, what you see online, when somebody asks you a question, can I help you, right? That is again based on machine learning algorithms. Okay. What are the various machine learning types?
Supervised learning and reinforcement.
Supervised and reinforcement.
A and D.
This was the puzzle which everybody makes mistakes.
Oh.
Supervised learning, yes. Learning association, why it is not? Learning association is part of unsupervised model.
Oh.
If you see supervised model, we talked about clustering. Unsupervised model, we talked about clustering and learning association, right? Which I talked to you about the recommender systems in the beginning of the session, first session, right? So it is supervised learning, learning association, and reinforcement learning. Question number 3, in Python, which of the following library can best help manage data sets?
Pandas.
Pandas.
Yeah, this is very simple. Let me see who can, and I think I must have explained this so many times, you should be able to sequence the following data pre-processing steps from the first step to the last step.
So first is importing data set.
Okay, good.
Then
Categorizing data.
sir, then we go for the missing data.
Categorize.
Categorizing data. Features failings, then splitting data into training and test set.
Anybody else? You're close, but I think you are still miss out something.
Sir, categorical data will be the last step. Before that, the splitting data will be there.
Anybody else? So you had the import data set, obviously. Then you had missing data. See, you cannot do categorization without you incorporate all the missing data. Please be understand. How do you categorize if there's a missing value, for example, right? Categorization data, yes. Splitting data is next, and then feature scale. If you remember, we did feature scaling on X train and X test. Remember?
Yes.
That means X train and X test only comes into picture when you have split the data. So splitting has to be first, and then you do the feature scaling. Question number 5. Which of the following is not a recommended strategy to take care of missing data? Yes, please read the question correctly, carefully. Which of the following is not a recommended strategy to take care of missing data?
Sir, D.
D for Delhi.
Yes.
Okay. Anybody else?
Yes, sir. B.
B.
Sorry, who said B?
Sir, C.
Delete the observations that contains the missing data.
Correct. See, if you remember, when I did the missing data, I showed you the script, right? Where did I use the mean to fill up the missing data? And then I could have used the median, I could have used mode also. See, if I delete my data, I will have less amount of data for doing the training. So deleting the data should be the last option and should be done in concurrence with the client, because the ownership of the data lies with the client and not us as a data scientist. Okay, so deleting the observation is something which is not a recommended strategy. Where are dummy variables used?
Data categorization.
And which function is used to do the data categorization? To do these dummy variables? Remember? We talked about label encoder, one hot encoder, remember? So we had label encoder which created the serial numbers and the one hot encoder which created the dummy variables. Okay. Which of the following are the Python libraries?
All of the above.
Sorry, ma'am, can you be a bit loud?
Sir, it is not visible clearly. Make it zoom, sir, little bit zoom.
Should I zoom it? Okay, no worries,
Yeah,
1 minute.
Not clear.
No problem. Can you see it?
Yes,
Can
sir,
you
yes.
see?
Good. It's good now.
So which are the Python libraries? Ma'am, you were saying something?
All are.
All of the above.
Correct, all of the above. So you have NumPy, sklearn is scikit-learn, which you use that, it's used in multiple places. Matplotlib, we talked about pandas. Which class is used for categorizing data?
B.
Label encoder. This.
Achha, please note that it is multiple choice. It can't be single, need not be a single answer. Okay. So which class is used? Label encoder and one hot encoder. Both, right? Label encoder and one hot encoder. Which is the recommended, sorry, what is the recommended ratio of splitting training data set and test data set? I think this we have done so many times.
70 to 30.
70-30 is one option. Any other option?
80-20, 90-10.
90-10 is also option possible. But yes, 70-30, 80-20 is the recommended options, right?
Correct. Correct.
Which are the various algorithms used in supervised learning?
Good question. Yes.
They're very interesting. I will tell you something about NLP, but what is your answer?
Associated learning.
Associated learning is unsupervised.
Sir, the linear regression and logistic regression comes under supervised.
Correct. So linear and logistic. Logistic comes under classification. Linear regression comes under regression, right? NLP. I will talk to you about NLP. Why it is also a valid answer. Okay. Now, for example, I go to a restaurant. I have my food, and at the end of having my food, most of the big restaurants, they will take a feedback from you to find out whether the food is good. Can I unmute? Can you please unmute somebody else? Somebody is speaking. Can others go on mute, please? It's creating a lot of disturbance.
Deena Babu, Dr. Deena Babu, please unmute. Dr. Deena Babu.
Sir, as a host, can you mute, sir? Sir, as a host, can you mute, sir?
Yes, sir. No.
Okay, thank you, sir. Thank you. So when we go to a restaurant and we take, after we having your food, we take a feedback. The restaurant takes a feedback. That feedback data is actually fed into a machine learning algorithm. And there are natural language, NLP stands for natural language processing. There are NLP libraries which can identify a particular word which says good about a product or which says bad about the food, right? So using NLP libraries, so you can have something called a classification data set, where based on the data you have entered in the feedback form, okay, you can say whether it is a good feedback or bad feedback. That data goes into a machine learning algorithm which has already been trained on that set of data earlier, and it will tell you that this particular comment that this person is given is a favorable feedback or an unfavorable feedback. So that is why NLP is also used very heavily for classification data, right? That's why the answer is A, B, and D. Let me see who can answer this. What is true about classification?
Level data confusion matrix.
Okay, very good. Anybody else? So you have labeled data, correct? Because you have fixed. Yeah, why D? Good point. Why D? Where did you hear the word prediction boundary?
Sir, I heard it in categorical data analysis once.
So if you remember when we talked about the logistic regression, that when you saw the graph, right, there was a straight prediction boundary line which was dividing the predicted 0 value and predicted 1 value, the red and green. That becomes the prediction boundary. So that is used in logistic regression. So it is B, C, and D. Okay. Okay, I think that covers most of the thing. Let's go back to the decision trees. Now, what is a decision tree? Typically, is in any decision tree, I will have a root node, a normal node, a parent, you can call it a parent or a child, you can have sub nodes, and you have a leaf. Leaf is the lowest level of the node. And in a classification data, the leaf is basically the value of the dependent variable. Either it's is going to buy a car, not going to buy a car, or is going to have cancer, or is whatever. The output value of a discrete variable. Now, if I have to show you this diagram, let's say I have got two features, x1 and x2. Okay. And these are the values. Green means 1, red is 0. Okay. And okay. Now, if you have this sort of a data, now how will machine learning algorithm create a decision trees? So this is a bit statistical, but just to give you an idea. Now there is something called an ID3 algorithm, which is used today. In that, what happens, you have something called an information gain or entropy. If you see the chemical term of entropy, means where entropy means it is less homogeneous, more heterogeneous. And when I say information gain, is that this ID3 algorithm, using some statistical way, it tries to calculate based on the attribute whether x1 and x2, one which is giving the highest information gain, or which is the one where you can split based on the basically splitting the plus the greens and the reds, the 0 and 1. So if you try to find the attribute which is having the highest information gain and then do the split based on that particular attribute. So when you have the high information gain, that means entropy is low. So you basically try to split from your parent based on the attribute which is having the highest information gain. And that is basically we use in decision tree classification. Now, if you go to decision tree regression, if you do some reading, there is something called standard deviation reduction. So the split happens in decision tree regression based on standard deviation reduction. In the case of decision tree classification, the split happens on an attribute based on having the highest information gain. Have you understood the concept, what I told you? Anybody has any questions on this? Okay. So if you see how the split has happened, this is how the split has happened based on this data. It has gone from this, then it has gone a further split, and finally what you see in the leaves is your either he buys a car or whatever he doesn't buy a car. I'm just giving an example, either 0 or 1. Okay. So this is how it internally does the decision tree classification based on the information gain. Okay. Now what I will do is I will use the same data set which was used for logistic regression, and I will run it for, I will use a decision tree algorithm to run that data set. So what I will do, I'll go back. I will keep the data set same. So I will change here. I will go back. I will select decision tree classification. I say select folder. And within here, I will see a file called decision tree classification.py. You see my data is the same. Now with decision tree algorithm, I will try to find out what is my accuracy. Okay. So I will use the same concept. I will go to importing libraries. This is all which was done earlier. I took age and salary as my independent variable and my purchase yes or no as dependent variable. I do the data split. I do the data scaling, feature scaling. Now I've used something called decision tree classifier and use something called criteria equal to entropy. If I use this, this will actually do the data split. Okay. Now if I do the Y prediction and I do the confusion matrix where I take Y test and Y prediction, you see here with decision tree matrix model, my accuracy is 91%. When I use the logistic regression model, my accuracy was 89%. right? So this way I calculate the regression, the confusion matrix or the efficiency of the various models with the same data set. And similarly, I can do a graph which will show me this is a bit, I'm sorry, this is a bit confusion, not confusion. This is not, this doesn't give you a linear prediction boundary as in the case of logistic regression. If I do this, this is how it looks. So you will have all the reds, which is demarcating the predicted 0 and 1 and the actual dots. Okay. Similarly, if I do for the test set, this is how it will look. Okay. So this is how a decision tree works. And for this specific set of data, you had the efficiency or the accuracy higher than the logistic regression. Any questions on the decision trees or any thoughts based on your knowledge which you have? Any, can you please share about decision trees model? Am I audible? I know it's close to lunchtime, but I think let's keep the same energy for next 5 to 10 minutes.
Yeah, you are audible, sir. You are audible, very clearly audible.
Okay, great. Okay. So having covered decision tree, as I said, one of the issues in decision tree is overfitting. So to eliminate overfitting, they have come out with an algorithm called, it's called the ensemble method, or it is also called the random forest. And what the random forest works is like this.
Sir, good morning, sir.
Sorry, somebody was saying something, then your voice is very low, sir. If you have a question. Okay. Now, how does a random forest or an ensemble work? It is still using the concept of decision trees, but the way it works is like this. I have a data set of say 1000 records. I will first decide how many decision trees I will take. Now, this again comes to experience. Either I can use 3 decision trees, 4 decision trees, 5 decision trees, and see where they and how many decision trees will help me to come out with an accurate model. Assuming I take 3 decision trees, I create 3 subset of records, say 300 records, 400 records, and another 300 records, 1000 records. I feed this into one decision tree model. I run it with the decision tree classification model. I feed this into another set of decision tree model. I run this with the decision tree model separately. What I done earlier, I will run it again with 3 different data sets. And then if there is a new input independent variable, this will predict some value of output, whether it will be 0 or 1. This also for the same independent variable, it will predict 0 and 1. This also will predict 0 and 1. So what it will do, it will aggregate the results and take the data with the highest vote. So if there are 2 of them, which is showing 1 and 1 is showing 0, it will aggregate and predict finally as 1 because 1 has the highest vote. If 0 has got the highest vote, then it will take the value of 0. So in a random forest, what happens, you have parameterized the number of decision trees and you find out, if I want to show it in a very nice form, pick up random key data points from the training set, build a decision tree associated with these key data points, choose the number of trees you want to build and repeat 1 and 2. Okay. For a new data point, make each one of the entries predict the category to which the data point belongs. Category means either 0 and 1, and assign the new data point to the category that wins the majority vote. So wherever you get the predicted value for that specific input value, among the decision trees, you pick that predicted value or the output which is having the highest vote. Have you understood this concept of decision random forest? Any questions on this?
Sir, how the data set is divided? Is it a horizontal division? It's not clear to me.
You have a random subset. You can do it you can use random state out there. I'll come to that. You use a random state there. So it uses a random subset. Yeah, that algorithm takes care of that. Okay. Now, if I want to execute here, I go back to my script. Now you have understood the concept. I will close this. I'll keep the data set same because I'm using the same data set. I will select this. I will go back. I'll go back. I will select random forest. Select folder. I will select random forest.py. Now what I do is I again run the data set. Same thing. I use the same. This is also same because I do the feature scaling. Now here, see what I'm doing. Here the random state 0, right? So the algorithm takes care how do you want to split the data set into. And here you see the number of estimators. These number of estimators is the number of decision trees which you have to input as a parameter. So you try with 5 decision trees, you try with 7 decision trees, 10 and so on, and then try to find out through confusion matrix which is giving you the highest accuracy rate. Okay. So for 10 decision trees, I run this. I do the prediction again. I calculate the confusion matrix, and now I calculate the CM. So again, it comes to 91% here, same as decision trees. So typically you will vary the number of decision trees and try to find out the confusion matrix, okay, and suggest the one which is having the highest of. So you'll have a threshold after which even if you increase the number of decision trees, the accuracy is not going to increase. So you need to have a threshold where you can say this is the one, this is the number of decision trees I need to select, which will give you the most optimized accuracy in my classification model. So this basically is called the random forest, or it's also called the ensemble method. Okay, so what we have seen is we have used the same data set. We ran the logistic regression, found the accuracy. We ran the decision tree, ran the accuracy. We ran the random forest because that is more recommended because of the overfitting issue in decision trees. And we find out we vary the number of decision trees where you have the number of estimators, which is the parameters, which is the variable, which you can change and find and play around with that. And find out the optimum number of decision trees, after which your accuracy is not going to increase anyways. I mean, these are very interesting algorithms, which are, if you really want to do deep search, you can do that. But yes, I mean, there are a lot of experts who have really worked on this. But have you now understood the concept of regression and classification as part of supervised model? Do we have any questions before I wind up? Have you guys enjoyed the session or not?
Yes.
Yes, sir, pretty much.
Yeah, important is when you go out of this session, I want you guys to be knowledgeable with something so that you can use it for in whatever way in your life or in your teaching career or so on. So I'll be sharing this PPT to sir, and he will share the PPT, the data set, and the scripts by tomorrow morning to sir. Sir can share it with all of you. I think tomorrow is your last day of this session. You'll be surely getting it before you go, before you finish off by tomorrow evening. And if you guys need any help as a part of your faculty for your students, please reach out to me on my email ID. Sir can share you the email ID. Sir can also share my number. You can take the number from sir, and then you can call me, and you can take a reference that you had attended some of my sessions, and I'll be happy to help your students. Today I have got association with around 62 colleges all across India, including the NITs, and all my faculties, including me, are working professionals. So today I've taken off. Actually, I told sir that 11 to 11:30 is my meeting, so I was not able to attend. So I had actually a meeting, official meeting between 11 and 11:30. That's why I requested sir to please start half an hour early. I'm very thankful to all of you that you are a bit flexible to start half an hour early and attend this session. Thank you very much, sir. Thank you, everybody.
Thank you,
And sir,
thank
if you
you.
want to conclude, then we can.
Participants, if you have any questions, please ask before winding the session.
So please share the email ID.
Yeah, sure.
Sir will share the email ID and phone number with all of you.
Yeah, I will share it. Before that, if you have any doubts, you can ask. I think this is a lunchtime, sir, so people are in hurry.
I'm also equally hungry, sir.
Yes.
So the
Really,
challenge,
yeah,
but
really
I hope because I think it's always good to do hands-on so that people can link the theory to the practical. Otherwise, just doing theory
Yes, sir,
becomes a
yes,
bit
yes.
boring, sir.
Both are required. So really wonderful session, sir. We enjoyed your theory and the practical sessions, and most of the participants are actively participated, and they cleared so many doubts. And thanks to our Professor Mallikarjunappa sir, his special interest on this workshop, and I think he is joining daily. Sir, he is
Thank you, sir.
a commerce professor, sir.
Thank you, sir. Thank you for the opportunity, sir. Thank you for the opportunity, sir.
Thank you.
Sir also actually asked so many questions and made the session very interactive. And so I hope all the participants benefited from these two sessions. Okay, if no questions, we'll go to wind up. Rahman, please proceed. Manas Rahman.
Yes, sir. Thank you, sir. And I will call upon Ms. Shibina to deliver vote of thanks.
Thank you,
Shibina.
Manas. Thank you, Manas. Respected faculties, dear speaker, students, scholars, and all our participants who have gathered here. It's my privilege to do vote of thanks on behalf of the Adult Academy and the Department of Computer Science, Central University of Kerala. I would like to express our sincere gratitude to our speaker, Arunjit Chaudhary sir, for his excellent presentation and an interactive session. Also, sir have taken two informative sessions and gave a deep insight into the area of machine learning and made it very lively by interacting with our participants. Thank you very much, sir. And I hope
My
it will
pleasure.
be beneficial. Okay, sir. And it will be beneficial for us in our studies too. Also, we hope you will support us for. Thank you, sir. And I thank all our participants for their keen attention and active participation during this session. Thank you all once again. Thanking you all for your support and cooperation. Thank you.
Thank you, sir. Thank you, everybody. Bye-bye.
Thank you, sir. Thank you very much for your active role in these two sessions. On behalf of the Department of Computer Science and Central University of Kerala, we are very thankful to you, and we hope your future support also to the department.
Sure, my pleasure, sir. I'll be more than happy, sir. Thank you very much.
Thank you, sir. Sir,
Thank
Kumar,
you very
sir,
much.
thank you.
Thank you, sir. Thank you.
Yes. Thank you, sir.
And the next session will start by 2:30. Participants, please join 5 minutes before. Okay. I will share the mail ID in just a minute. I'm just looking. I will share his number. His number is 98205 98205 29962. 98205 There is a number of Arunjit Chaudhary. Mail ID Manas. That brochure mail ID is there. Profile.
Yes, sir.
Profile mail ID. Is
I will check it out, sir.
It is there. I have.
Okay.
CBTS1 dot. If you written like that, capital CBTS. CBTS 1 dot 2013 at the rate of gmail.com. ebps1.2013@gmail.com. So that's the mail ID. So participants, please join 5 minutes before. So I'm winding up the session. Thank you guys. Thank you all.
Okay, sir.
And,